let's go. Or the base of the solid whose cross sections is perpendicular to the x-axis are squares. So we're going to have g of x, x-axis, minus f of x, from squared from 0 to q. 0 to q. R of x to the base of a solid whose cross sections are perpendicular to the x-axis are squares. What's the volume of the solid? So we have f of x minus g of x perpendicular to the x-axis. So if x-axis would be y equals 0, so y is equal to a function of x, so that's correct. So those are inverses, or not inverses. Integral from 1 to 5. Sure. 1 to 5. Oh, does it give us the value? Oh, it does. So integral 1 to 5 of f of x. They're all 1 to 5. F of x is negative x squared plus 6x minus 3. We get minus, I'll just say plus 1/2 x squared minus 3x plus 1/2 integral 50 of we get negative 1/2 x squared minus plus 3x minus 5/2. There we go. That's what I got. The region R is the base of a solid. What is the value? So we have integral perpendicular to the x-axis. Okay, so that y equals 0, so y equals x. F of x, so we have g of x minus f of x. The integral from 0 to 3. From 0 to 3. Whose height is x equals 4. That area times x minus 4. Sure. I think that works. Sure. So we have x squared, g of x is equal to x minus 4. That's nifty. X minus 4. So x minus 4 minus x squared, x minus x squared minus 4x plus 4. Okay. If we substitute, we get 4 minus x squared plus 4x minus 4. We have negative x squared minus plus 3x. We get 0. 4 minus x from 3 to 0. I got 3x minus x squared. 3x minus x squared for 3, 0 to 3. Yay! Here is the base of a solid for each x value. The cross-section taken perpendicular to the x-axis is a rectangle whose base lies in R and whose height is q minus r. Okay, which of the following indefinite integrals gives the volume of the solid? Let's see. So we have the integral, x-axis, so y equals 0, y equals f of x. We have height, so from the integral from p to q of q minus x times f of x minus g of x. F of x minus g of x. There we go. From q to p, q minus x, it's not going to be squared. This is a rectangle. Yay. Let Q be the region enclosed by y equals 3 minus x squared and the x-axis in the first quadrant. Region R is the base of a solid whose cross-section perpendicular to the y-axis are squares, which of the following definite integrals gives the volume of the solid. So we're going to have the area. It's perpendicular to the y-axis. Okay, so we're going to have y-axis, that's right here. So we're going to have x equal 0. So we have to get this function as x. So we have x we have y minus 3 times we'll get x squared. We'll have x squared plus y equals 3. X squared is equal to 3 minus y. X squared is equal to square root 3 minus y. Okay, so we have square root 3 minus y minus 0. Or squares, so we're going to have from, this is y equals, so we're going to have, for the y values, we have 3 and 0. So from 0 to 3, these are going to be like that. Smaller and smaller and smaller. Let's put nice yellow like this. Very small at the top. And square this whole function. Yeah, so it's really just 3 to 0, 3 minus 1 dy. Yep, because the square root gets cancelled with the square. So the base of a solid is the region enclosed by the graphs y equals 2 plus x over 2 and y equals 2 to the power of x divided by 2. Between the y-axis and x equals 4. Cross-sections perpendicular to the x-axis are rectangles whose height is 4 equals x. What gives the volume of the solid? Okay, so you have the integral. The integral of This is an exponential function, so that's going to be the minus. So we have 2 plus x over 2 minus 2x over 2 between x-axis and y equals 4, perpendicular to the x-axis. So you have y equals 0, y equals f of x. Okay, so y equals 4, so we have from 0 to 4 of this function, and we're going to have 4 minus x. There we go, whose height is 4 minus x, which the following gives the volume of the solid. Yeah, that sounds about right. 4 minus x, 2 plus, that's all I have. Orbit the region close by the curve y equals log 2x, and the line y equals 3 and x equals 3. Region R is the base of a solid whose cross sections perpendicular to the x-axis are squares, which the following definite integrals gives the volume of the solid. To the x-axis. So it's y equals 0. Y equals f of x. Okay. So we're going to have integral from 3 to wherever this point is, where log of 2 of x equals 3. So that's 8, from 8 to 3. Then we have this function, so we'll have 3 minus log 2 of x are squares. So you can have this entire function, we're going to square it, and it's going to be dx. So integral 8 to 3 minus log 2x squared. To the definite integrals gives the volume of the solid. Region R is the base of a solid for each y value perpendicular to the y-axis. So that's x equals 0. So x has to be equal to f of y. Okay. So we have 4. It's f of y. Four minus, you can get this in f of x. So we have 2y to the power of, all to the power of 1/3. 2y to the power of 1/3. Times y over 2 from the area of 0 to 4. Area from 0 to 4, 4 minus 2y, let's get to x cubed. X is equal to 2y to the power of 1/3. This seems to be closest, but perpendicular to the y-axis. Height is y equals minus 2. So we have to have y minus 2 in here. From 0 to 2. That interval doesn't make much sense. But this is the area under the curve right here. What? I'm confused right now. It should be cube root of 3. No, the intervals are from y. F of y, so it has to be from y. So it definitely can't be B or C. D is it D just because? Ooh, it's to this point right here. Is that what that's saying? It's dy. Perpendicular to the y-axis. Yeah, I think that's what it's saying. Oh, I got that. Oh, just the first note. I got this part, but then I did 4 minus because I thought I was doing the other side. Okay, I see. Yay. A few more videos left.